Here the core part of nuclear reactor. Here the walls are constructed with concrete and the inner layer is coated with lead. Why? Because in the fission process the fragments emit the harmful alpha, beta, gamma rays. That's why to absorb them the inner layers are coated with lead and the walls are constructed with concrete. Here in cylindrical cans the uranium source is taken and into the uranium source neutrons are sent, then immediately the fission process starts. In each fission 3 neutrons are emitted. To control the chain reaction, here the control rods are dropped into the core part. In this rate, suppose 2 neutrons are absorbed by the control rods, immediately the 1 neutron again continues the fission process. To slow down the velocity of neutron, here the moderator rods are dropped into the core part. Here they are dropped simultaneously, then moderators slow down the velocity of neutrons and the control rods absorb the neutrons. When they send one after the other into the core, immediately the chain reaction is controlled and you can generate the heat inside. That heat is converted into electrical energy.
Chain reaction occurs within the core and energy is liberated in it. When chain reaction takes place, the core of the reactor emits a number of neutrons, beta rays, high energy, gamma rays, etc. These high energy radiations are very harmful to human body. To prevent leakage of such destructive radiations, the core is surrounded by a thick layer of concrete containing a mixture of heavy and light elements entirely on the law of charge. That is, the number of atoms breaking per second at any instant is directly proportional to the number of atoms present at that instant. This is also called statistical law of radioactive decay. We may write minus dN by dt directly proportional to n. Here negative sign simply indicates that n is decreasing with time t. Thus minus dN by dt equals to lambda n, where lambda is a constant of proportionality called decay or disintegration constant. Its value depends upon the nature of the radioactive substances. It is different for different radioactive substances.